Okay, so the first thing we're going to work on is a piecewise function. Okay, a piecewise function. So a piecewise function is what it sounds like. We have pieces of separate equations put together for one function. Okay, so you're going to have two or more pieces, and they're going to have restricted domains so that when you put them together, we have a domain of all real numbers. They can't overlap, otherwise we don't have a function anymore. And then together we are going to make this piecewise function. So write it down. They'll always be like those braces to connect them together so you know they belong together. Okay, so you'll notice that like we have this brace connecting our multiple pieces. In this case, we only have two pieces. But each piece is going to have a specific domain. So 2x plus 3 is only when x is greater than or equal to 1. Negative x plus 4 is only when x is greater than 1. Well, when you squish these two domains together, we have all real numbers. Okay? So these are not going to overlap at all. But which makes it a function. Okay, so we just have the two separate pieces. Now, we are going to go ahead and graph this. We're going to graph this one together, and then I'm going to give one for you guys to graph together at your tables. Okay? I am going to make an XY chart just to help you get started. You do not need an XY chart. As long as I can see where your coordinates are, I'm really okay, because I think that you can do this without making an XY chart. But I know for some of you this is going to help your organization. So I'm going to make an XY chart for 2x plus 3. Where should I begin my XY chart for 2x plus 3? Should I begin at 5? Should I begin at negative 3? Where do you think I should begin?
Wouldn't it be 3? Because if it's 2x, wouldn't it be above, like 1 above?
Are you talking about like the y-intercept?
Yeah.
Okay. I agree that our y-intercept is 3. But look at this right here. We're going to have the coordinate 0, 3. Thank you. But we want to make sure that we don't go past a certain point. Okay? So this domain piece begins at 1, right? So I agree. We need the coordinate when x is 0. But let's begin at 1 and make sure we don't go past 1. We only want values 1 and below. Right? That's what that domain is saying. X is less than or equal to 1. Okay. So what's our y value when x is 1? When x is 0?
3.
Okay, so there's your y-intercept. And when x is negative 1? Okay, so we only have a piece of our line. Okay, now when we make our XY chart, and like I said, you don't have to make this for negative x plus 4, okay, we're always going to look at this domain piece right here. So our domain piece is saying x is greater than 1. I know that we're not including 1, but 1.0001 would be included, right? So what we're going to do, we're going to begin at 1, but we're going to make sure that we have an open circle there. Because we don't include 1, but we include everything past 1. Okay? So 2 and 3 are fine. Okay? So when we plug in 1 to negative x plus 4, what do we get? So we have an open circle at 1, 3. Then we have a coordinate at 2, 2, 3, 1. And I think that's enough for us to figure out what our line is going to look like. Okay. The only open circle is occurring at x is 1 because we don't include it in that piece, but then everything else is solid. Okay. So now look at our graph. Does it pass the vertical line test? Okay. Here at the break in the domain, we have an open circle and a closed circle. So we're still passing the vertical line test. Okay, we still have a domain of all real numbers, even though we pieced it together. Okay. Write down on your notes what you think the range would be. Jack, what do you have for your range?
Well, it starts at 5 at the top,
Mhm.
and it goes to negative infinity.
Okay, it starts at 5 at the top and goes to negative infinity. So I'm going to write it in this order. Okay, and then will there be a bracket or parentheses on 5?
There'd be a bracket.
Okay, there'd be a bracket because we do include that value. Good. Yes.
The question of the x's, because the negative x plus 4, if like I get like the open circle, but one is still like included in like the x part. I just don't.
So since it says x is greater than 1, we need to begin our piece at 1. But since we don't have that including 1, we notate it with an open circle, and then everything else can be included. Okay, that way it's still going to pass our vertical line test because we have a closed circle overlapping with an open circle. Does that answer your question? Okay. Okay. So what I'm going to do, I'm going to go to the next slide. And on the next slide, there's a piecewise function that has 3 pieces. And I'm going to give you about 4 or 5 minutes to work together at your pod to come up with what you think the graph looks like. Okay? I'll walk around. You can ask me questions as we go. But I want to know what this graph looks like. Okay? In my opinion, you know what each of those 3 graphs would look like separately. Okay? And you can use that knowledge to help you. Okay? I don't think in any 3 of those graphs are something you couldn't give me individually, but I just need them with these domain restrictions. Okay? I don't want it quiet in here. I want you to be working together with your pod and communicating with how you think this needs to look. Okay? I know you're writing it down right now, so it's quiet, but once we get going, I want you to be communicating with your neighbors.
Yeah, so it has to be. So I'm just gonna do X, Y. So yeah.
That's I wanted zero negative one because if it's less than one, equals plus, it's greater than negative two. No, when you go zero negative one, so it's greater than negative.
Yeah, there's only 3 points. Actually, there's 4.
Zero squared is zero.
Are we supposed to do this without a calculator?
You should be able to do it without a calculator.
If there's 4 points, do we just use all 4 points?
Yeah, I was using 3 coordinates, but if you need more or less, okay, 2 would be minimum, but if you have more than 3, I'm not going to complain.
And for the last one, I just like 1, 2, 3. And then my y is 1, 0.
Okay, so if this one
Actually, yeah, maybe that's right, because that's what happened to us, that's what we
Just make a straight line and curve it
Down.
you did, so that's going to help you.
When we're graphing, like, so it comes down here and it comes back up, sometimes it doesn't have to be a straight line.
Well, what do you think x squared should look like?
Second one would be going up because the
Okay, so does that look like a piece of a grappler? Okay,
Yeah.
yeah, always think about what it would look like as a whole,
And then
and then,
So, wait, for the second one, we're
adjust
including
for your
-2
rates.
and then graph, right?
oh yeah, it needs to be curved because
Okay.
it's a parabola.
Yes.
So,
So why?
So did these fine? So, it can just like overlap, so you have your closed circle, open circle on top of it.
all
So
the same
basically
part.
that closed circle is coloring.
the domain
Oh,
is
it's
all
close to the
I literally just saw something.
Is it just, whatever you, it's what?
Yeah. Because I saw you. circle. So like this, like X. So like yeah, you know, right.
Yeah, so the domain is the same, it's just negative infinity.
So we like, we're done with chapter 1, like, put everything in
Range
folder,
is
or
negative infinity to 4.
Yeah.
Alright.
It's okay if we write
Okay, I'll give you about 1 more minute, maybe.
Water B, what's the range?
Because of the second one. It goes up.
I feel so dumb.
Basically, because as it moves left, the R value will increase because it's X squared.
Oh, I thought it ended at -2 because since it says.
Oh wait, I mean, well, actually that doesn't.
It includes -2.
I wrote the right answer on the quiz, and then I just didn't write it, like saying how, if you do whatever, like, there's a line in the right answer.
Yeah.
I wrote the right
So it's
answer.
very good in that number. Only go for 4 because it says
Okay, let's talk about this. So, for your first piece, you should have an open circle at, is it -2, 1? And then you have a line with slope 1. So it should look like that. Okay. A little bit crazy. For your last piece, -x plus 2, we have a closed circle at 1. Is it 1, 1? Right. And we have a slope of -1. There would be those two pieces. Okay? Your middle piece, you need to start at -2 and end at 1. Some of us were not going all the way to 1. Some of us weren't including -2. Okay? So at -2, we would have a coordinate at 4, and it would need to be an open circle, or excuse me, a closed circle because we include it. -1 has an output of 1, 0, 0, and then you do, since our domain cuts off at 1, we do need a coordinate at 1, 1 with an open circle. Now, notice how our open circle and closed circle are overlapping? Okay? That's fine. The closed circle is just filling in the hole. So it ends up just looking like a closed circle. Okay? But please make sure you know what this looks like. You know that this is a parabola. Please make it look like a piece of a parabola. Have it curve. Okay? Arrows signify that our graph goes on forever. Does this parabola go on forever in either direction? No. So there are no arrows either way. Okay? So a couple of things that I saw some arrows right here, and I saw some people not getting this little piece right here. Okay, make sure you, like in the case where we have more than 2 pieces, make sure you get both of the end caps of that domain, even if there's not that equality there. Okay? Are there any clarifications I can make that I haven't gone over yet? Okay. A lot of groups were already talking about domain and range. Thank you for those of you who went ahead and talked about that. Okay. Our domain, everybody, what is it? all real numbers, okay? Our domains squished together make all real numbers. We don't have to write them separately. We can just squish them together for all real numbers, okay? But our range, Devin, what do you have for your range?
I had like y being less than or equal to 4.
Okay, so in interval notation, we would have negative infinity to 4. And would there be a bracket or parentheses? Would we include 4 or not?
Yes, so it would be
Okay.
bracket.
So we would have a bracket, 4 and below. Okay. Very good. Okay, are you ready for our new function? Okay, did anybody look up what the greatest integer function was? In the back of their book. Okay, yeah, I like it. So what I'm going to do, I'm going to show you the graph. And I don't want you to write anything down quite yet. I just want you to talk about what's happening. How, if this is, so this is our notation. These double bars mean greatest integer. Okay. If we are inputting numbers for x, how are we getting outputs that create this graph? Okay. So when I'm plugging in a number, its output is here. Okay. So there's closed circles and open circles, and then there's horizontal lines in between. I want you to take about 60 seconds or so and talk about how you think this double bar line, this greatest integer notation, how is it calculating those outputs? When you input an x, how is it getting the output to make those little stair steps? Talk about what you think is happening. Make observations.
It's don't have one. I have no idea. It was a 1 and 1. It doesn't mean anything. It's the greatest integer.
Just make observations.
I mean, it has a pattern like this.
We're out of observations.
What?
We're out of observations.
What observations did you make?
I don't even want to say it.
Line 1.
Like, try plugging in numbers, integers and non-integers, and figure out where their outputs are. So where's the coordinate on the graph? Think of non-integer values to plug in for x, and where are they on the graph?
This is what you see when you line up.
So it's just pointless.
Okay, so share with me some observations.
The domain is all real numbers.
The domain is all real numbers. That's a good observation. What else?
Yeah, it's a pattern.
And what's the pattern?
It's like closed circle, open circle, closed circle, open circle. And also it goes up by 1.
Okay, so we stretch here for 1 unit at a time. Okay. Okay, so we could connect these solid dots and it looks like the line y equals x. Okay. How are we getting those stairs? What? Okay, it's going over 1. So I want you to think about, like, what's the x value right here?
1.5.
Okay, so our x value is like 1.5, and our y value is 1. What's like the x value right here? 2 3/4, and our y value is 2. What's the x value right here? 3 1/5. Sure, sounds great. What's our output? 3. What kind of numbers are our outputs?
Integers.
Oh, integers. The greatest integer function. Okay. And what kind of integers were all of those compared to their outputs? Were they bigger? Were they less? Here, our input was 1 1/2, our output was 1. Here, our input was 2 3/4, our output was 2. Here, our input was 3 1/5, our output was 3. What kind of integers are those? They were smaller. Okay, our greatest integer function means we are taking, I'm going to get, our input, like when we input an x, our output is the greatest integer less than or equal to x. So whatever we put in, that double bar line calculates the greatest integer less than or equal to x. Okay, so when you have that written down somewhere, I want you to get your pink sheet out and I want you to draw in the graph and the equation. Somebody even already mentioned the domain for you to write down. Okay, go ahead and fill that in for your pink sheet, making sure that the closed circle is on the left and then our stair step goes out to the right. Some people may call this the stair step function because it looks like a set of stairs, right? Okay, and then we're going to practice using it, and then we'll be done. Okay. So I would only worry about the y-intercept, which would be this right here. Technically, we would have an infinite number of x-intercepts because we have an infinite number of coordinates sitting here on the x-axis, so don't worry about it. Also, don't worry about the range, okay? The range is broken up. I mean, the range is all the integers, so if you want to write that, you can, but it's not something I'm going to ask you for because the notation would be crazy, okay? But it's broken up by just the integers, okay? Not going to make you notate that. Okay. So then, what I'm going to do with these pink sheets, this afternoon during my plan period, I'm going to put my key up online. And I want you tonight as part of your homework to make sure that your pink sheet matches my key. That way when we use them tomorrow in class, we're all on the same page with notation and graphs, okay? Because tomorrow we're going to take these parent functions and we're going to shift and stretch and shrink them, okay? Reflect them, all sorts of cool stuff, okay? So let's practice this greatest integer function. The greatest integer of 3.4. So remember, our output is the greatest integer less than or equal to the value. Turn to your neighbor, tell them what you think it is. Integer. The greatest integer less than or equal to 3.4.
Trace.
Mia, what do you think? 4 or 3? Mia's not sure. Let's help her. Okay? The greatest integer less than or equal to. There we go. 3. Okay? Some people might call this like the floor function. We're always going to round down to the nearest integer. Okay? Careful. Negative 1.5. The greatest integer less than or equal to negative 1.5. Oh, gonna have you think about it, but you're all telling me. Negative 2, we're rounding down to the nearest integer, and negatives, and we have to go down. What about this one, the greatest integer of 2? 2. When it's an integer, it gets to stay the same. Okay? Don't overthink this. The greatest integer of 4.99. Think about it. Don't say anything. Turn to your neighbor. Tell them what you think. Okay, when I said that, I heard this whisper of 4, 4, 4, 4, 4. Okay, I didn't trick you. The greatest integer, excuse me, less than or equal to 4.99 would be 4. Okay? All right, so in your homework tonight, you have a couple, who has their goals down?
Yes.
Jacob has his goals, yeah. I think you have a couple graphs and a couple practice the greatest integer function. You have 1, 2, 3, 4 problems to do tonight. And check your tape charts. Okay? And remember, I have that column of extra practice. If you do the 4 problems tonight and you're still not really feeling it, take a couple of the extra ones to do. Okay? That's what they are there for. Okay?